Hello, this lesson is about the Pythagorean Theorem. So, first thing is this. Draw a picture of the problem or the situation if the picture isn't already provided. Identify and label the legs and the hypotenuse. Substitute the known values into the Pythagorean Theorem. Square the known values. If a leg is unknown, isolate that variable part. Take the square root to find the value of the remaining variables, and round if necessary. So what we mean is this. Here's an example. This is a right triangle. Pythagorean theorem essentially says a squared plus b squared equals a c squared. It says a to the second power plus b to the second power equals c to the second power. A and b are the legs. They're the sides that make the right angle. You might even say they're the two altitudes. But yes, they're the legs. The hypotenuse is the side opposite the right angle. We call that side C. This is A, this is B, and this is C. The hypotenuse is always opposite of this right angle. All right, so basically if you're going to plug in A, B, and C, A is 10, B is 13, C is unknown, or X. So when you square 10, you get 100. When you square 13, you get 169. And C squared is still C squared. 100 plus 169 is 269 equals C squared. To finish solving that, you square root 269. You square root C to the second. By taking the square root of both sides, the left side becomes 16.4. And the right side is just C. If you plug in the calculator 269, the square root of 269, you should get 16.4. So just to prove it, I'll plug into my calculator the square root of 269, you should get 16.4. That's why the answer there is 16.4. All right, so that's how it works. Sometimes you're given one of the legs, but not the other leg, and you're given the hypotenuse. So in this case, this would be A, this would be B, and this would be C. So you plug it in, it's going to be A squared plus B squared equals C squared. So A squared plus 12 squared equals a 20 squared. 12 squared is 144, 20 squared is 400. To isolate a to the second, you subtract 144. You get a to the second equals to 256. And when you square root a to the second and you square root 256, the square root of a to the second is a to the first. And the square root of 256 is 16. So that's how those work. Let's do one on our own. All right, here's another example. It says determine the missing side. So these two sides make the right angle. So these are my legs. This is a leg, and this is a leg. Each of these legs are either A or B. You can name any one you want. And this part has to be the hypotenuse. So this would be C. I would always start by writing the formula A squared plus B squared equals a C squared. And then if that's true, that would give you 28. So 28 to the second plus 21 to the second equals a C to the second. And then you just evaluate 28 to the second plus 21 to the second. 28 to the second is 784. 21 to the second is 441. Equals C to the second. When you add these, 441 plus 784 is 1225. Equals C to the second. So to finish, you would square root the left side. You would square root C to the second. So the square root of 1225 is 35. 35 equals to C. So C has to be 35. So the hypotenuse in this problem has to be 35. I'll give you one last one, and because this one has an x as the hypotenuse, my next one won't. So here, it says determine the missing side. And here, this part would be A, this part would be B, this part would be C, the hypotenuse. So if A squared, block this off. So A squared plus B squared equals to C squared. A is 12, so 12 to the second. B is X, so X to the second. And C is 12.5, 12.5 to the second. 12 to the second is 144. X to the second is just that. And 12.5 to the second is 156.25. So 156.25. And our goal is to isolate x to the second first. So I'm going to subtract 144 from both sides. And I'm going to use this side to finish it. So x to the second equals to that number, subtract 144. It's 12.25. So if that's true, I will square root the left and right side. So x is the square root of 12.25. So 3.5. So this side has to be 3.5. So we solved for x in each one of those. That's all I have. Good luck.